In this video we have two integrals to evaluate, and it's not always clear what method to use. But one of the things you want to do at the beginning is see if a U-substitution will work, and then go to the other methods, integration by parts, partial fractions, and so forth. So if we look at the first one, we're going to look at U-substitution. So notice here, if you look at this integral, we have 1 over x here. You can look at dx over x, but there's 1 over x there. So the key to these U-substitutions, if you can find a derivative somewhere in the integrand, it'll give you one of the main terms. In this case, the derivative of ln of x is 1 over x. So notice, if I let u equal ln of x, then du will equal to the derivative of ln of x, which is 1 over x, and then the dx. So notice right here, I have dx over x. So I can replace the dx over x by du. The ln of x here, of course, is your u. So we can rewrite this as the integral. Now we're changing the variable. So the ln of x is replaced by u, and that's taken to the 5th power. The dx over x is replaced by du. And this is just over 1 here because I replaced it. So let's go ahead and remove this here. So now we just integrate with respect to u. Using the power rule for integrals, add 1 to the 5, we get u to the 6, and divide the coefficient by 6. So I can write it over 6, so I can write it as 1 over 6 times the u to the 6, plus the constant of integration. And then the last thing you always want to do is go back to the original variable. So the u is ln of x. We'll put ln of x here. And I could put the 6 here, or I could just put the whole thing in parentheses. Don't put it on the x here. That's not the same thing. So I can put the 6 here in parentheses like this. I can put it here. And that's over 6 plus the constant of integration. And that's your answer. Now in the second one, I got tangent of x times secant squared of x. So the derivative of tangent is secant squared. So let's let u equal to tangent of x. Then the derivative of u will equal to the derivative of tangent of x, which is going to be secant squared of x, and then dx. Now we convert the integral to one involving the variable u instead of x. So again, notice here, secant squared of x dx, right here, that's your du, and tangent of x is your u. So this can be written as the integral of u du. Got a 1 here as an exponent then, using the power rule again for integrals. We add 1 to the exponent, we get a 2, and then divide by 2. Or I can put I can write a 1/2 in front of here. I'll leave it that way. Plus constant of integration. And then this is equal to then u is tangent of x. So again, I'm going to write this tangent of x, quantity squared, so I could put it here, or I could put the whole thing in parentheses like this, square over 2 plus the constant of integration. So here's the answer for this one. Thanks for watching. We'll see you next time.